welcome to part 2 of motion along a straight line. Today, or on this video, we are going to use a sample problem to explore a bit more of the concepts that we saw on our last video. So if you haven't checked that out, I invite you to do so. We're going to be building on that knowledge. So it'll be important for you to kind of have the foundation for that, okay? My name is Jay Lu. I'm from toysandphysics.com. I welcome you to this part 2. And like I said, we have a sample problem. We're going to be exploring more of the concepts of displacement, position, displacement, and average velocity. Now, this site is called toysandphysics.com for a reason. Today we're going to be using an RC truck to kind of construct our situation here. And I want to invite you to use your imagination, because I'm going to ask you to imagine that you are driving this RC truck and you do it along a straight road for 0.7 kilometers at a speed of 20 kilometers per hour. Now, at this point, as every RC truck runs on battery, suddenly it stops and you finally understand that this RC truck has depleted the battery, and therefore you cannot keep on going. So you cleverly decide to go to the next and nearest hobby store to you, and you walk for 30 minutes, and 2 kilometers after you find that hobby store. Now, excuse me, this will be the basic situation. If this is the statement, the problem statement, then we are asked to find out a few things. The first one will be, what is your total displacement from the beginning of your drive until you reach the hobby store? Second is to know the time interval from the beginning of the drive, again, until you arrive at the hobby store. And last but not least, the third question is the average velocity for the entire trip from the beginning of your drive until you arrive to the hobby store. Something interesting here, and I want to show you more about that, is that we are asked to express our answer both with numbers in a graphic. There's the fourth question here, but this includes a little bit of a twist in the story. Suppose you get to the hobby store, you get a new or charged battery at least, and then you walk back to the RC truck for another 30 minutes. If that's the case, then what's the average speed from the beginning of your drive until you return to the RC truck with the new battery? Okay, so that's kind of the problem statement. There's the fourth question here with a little bit of a twist, and let's start with the displacement. So very simple to do. Remember that displacement is nothing more and nothing less than a change in position. So all we need to do is find the initial position x1, and then find the final position x2, which is the station. And remember that displacement along the x-axis is nothing more and nothing less than the difference between x2 and x1, or the final and initial position. So I have a very simple diagram here with an x-axis that's labeled in kilometers. And well, something I want to mention is that this particle moving here, this little circle there, it's trying to, it's there to show kind of the object moving, right? Since the x1 position which will be at 0 kilometers right here until its final destination. It's not representing the speed or the velocity or average velocity. So I don't want you to think this is moving like in real time or with the real average velocity. It's just a way and a mean to represent the displacement. Okay, so in this case, again, let's go back to displacement definition. That's delta x. equals x2 minus x1. x2 would be the of course, we already know x1, which is 0. It's the start of your driving. But x2 will be the 0.7 kilometers that you drove, plus the 2 kilometers that you walked until the hobby store. So if you do the difference, you get that the displacement is 2.7 kilometers for the total trip. Okay, so that's, like I said, very simple concept. Nothing to be afraid of. This is very, very simple. In fact, physics is simple. It's just a matter of start thinking about the situation, imagining this type of diagrams like this. They can seem simple. They actually are, but in many cases, it's quite difficult, I would say, to kind of imagine and picture the situation. That's one of the challenges and the skills as well that you develop while solving these problems. Even these like this one, which is very simple, it helps to develop that skill. So the more you do it, like everything, right? The more you practice, the better you get. So let's move on to the next question, which was the time interval for the entire trip. Again, this is, by the way, just wanted to mention, this is labeled here RC truck time interval, but we are also counting not just the time interval for the RC truck, but also the walking time, right? So it's just a title for that, but just wanted to mention that we are not just considering the truck or the drive time interval, but we are considering the whole trip. Even the walking part, okay? The walking part. Okay, so for the time interval, since you start driving until you arrive at the hobby store, all we gotta do is to find out both time intervals, that is the time interval for walking, and then the time interval for driving. And if we sum those two up, we will get the total time interval from the beginning of your drive until you arrive at the hobby store. Okay, so pretty simple. So we know that the walking time interval was delta t with a W here for walking, half of an hour, and we'll put it like this, 0.5 hours. But we don't know the driving time interval. All we know is that you moved 0.7 kilometers and you did this at an average velocity of 20 kilometers per hour. So with these two numbers here, we can find the delta t. So we can find that by using the average velocity definition equation, which is delta x divided by delta t. If we solve for delta t, we can substitute the numbers here. We have 0.7 kilometers divided by 20 kilometers per hour. We cancel the kilometers here, and we have the end result for the driving of 0.035 hours. Okay, so it's a very short period of time. Okay, like I said before, if we just sum these two, if we just add these two up, the entire delta t, it's excuse me, the time interval for walking plus the time interval for the drive, and that's a bit more than a half of hour. Okay, so that's the end result that's the total time it takes you since you were driving until you arrived at the hobby store for that trip. Okay. Now we are going to go with the average velocity of the RC truck, and remember that the question included. We're going to see that a bit more of that in this section, but it included to express. It asked us to express our answer with a graphic. So first things first, let's do this with the equation with numbers. So we know that the average velocity for the entire trip is the ratio of 2.7 kilometers, because that's the total displacement, to the time interval 0.535 hours. That's the total time interval for the entire trip. And we just substitute the values here, and we find out that the average velocity for the entire trip is 5 kilometers per hour. It's a bit more, but here's the result for you to check that out. You can check the numbers and the results. Let me know if you have any questions. Okay, so again, very simple stuff, nothing complex. nothing fancy. It's just we're applying the equations we already know and substituting values and going from there, solving from there. Okay, but the graphic, it's a bit more interesting because it's interesting to me because it kind of shows how it behaves. You can see the behavior of the particle, or in this case, you moving first when you're driving and then when you're walking, and you can kind of compare. You can reflect on that. So I think that's why I get and find that important and interesting, right? But it's not complex or hard or anything like that. Okay, so to find the average velocity graphically, we first graph the function of xt, that is displacement dependent on time, right? Where the beginning and the arrival points on the graph are the origin and the point labeled as hobby store. You'll see that here. Let me just continue to read this and we'll go to the graph here, okay? So the average velocity is the slope of the straight line connecting those 2 points. By the way, the slope, which is something that's more like a math concept, you can find that there's an equation for that. It's not here, but you can definitely research that. But at the end of the day, what I want to say is that physically, in terms of position and displacement and velocity, the slope of the straight line, that it's the resultant of the graphic of position versus time, is actually, it represents the average velocity of the entire trip. Okay, so that's something important to know, because that's when math and physics connect, and math starts making more sense in physics terms. So I think that's important to mention here. Again, the concept of slope, it's not developed here, it's not mentioned, it's not defined here. You can research more on that, but just so you know, the average velocity is the slope of the straight line connecting these points. That is the ratio of displacement in the time interval, which is the average velocity that we already know, which is 5 kilometers per hour, 5.046 kilometers per hour. Okay, so let's go and see the graph here. I want to go over the graphic with you. So we have a y-axis that will represent the position in kilometers, and we have an x-axis that represents time in hours. When we have to graph the function again, when we have to graph the function of xt, x depending on time, we pretty much do it this way. We go with time on the horizontal axis and with the position on the vertical axis. Okay, so these 2 points here, these 3 points here represent the movement of the particle, and it's kind of telling the story of what it did and how it went when it was moving. So it first started here at the origin. It was the start of a drive, and then for 0.035 hours it moved until here, which is 0.7 kilometers. Then the battery goes off and you have to walk, right? That's why it says driving and walking velocities. You have to walk until the hobby store. So at that point, you can see how this line here, it's longer on its x-axis because it takes more time. That's 30 minutes, half of an hour, for you to get to the hobby store. And also your speed goes down. So that's the reason why, again, the displacement, it's 2 kilometers here, right? So again, 2 kilometers, half of an hour. That's the reason why this line here, it's not just longer than this one, but also its slope, it's lower. Its slope, it's lower. And it's lower because your speed goes down since you're walking over a long walk and a long period of time. Okay, so that's why I was saying that you can kind of reflect on this and see how things go and what's the behavior of a particle that's moving. Okay, so Again, the slope of the blue line is the average velocity. It's just a ratio of these two quantities. And that's kind of the analysis you want to make with this type of graphics. Okay, so again, if you want to go in more detail, if you have any questions, by all means, let me know. You can check this out at toysandphysics.com. You'll see this same animation that I'm sharing here in this video. If you want to spend more time on it, by all means do so. You can find that there. Okay. And the last question, remember that last scenario when we said, what if you got the new LiPo battery? What would be your average speed? Since the arrival, I'm sorry, I mean, since you start driving, then you went to a hobby store and then back to the RC truck. So your average speed for that entire trip, and something that I want to disclose here is average speed should not be confused with average velocity. Average velocity or velocity is a vector quantity. That means it has both direction and magnitude. And the speed is just the magnitude of that vector. So that's important. Again, we're not touching a lot on vectors during this series of videos, but we'll eventually do it. But it's something that I want to disclose. Speed and velocity are different things. The difference is velocity is a vector quantity. Speed is just a scalar, which is just the it's just a number, the magnitude of that velocity vector quantity. Okay, so your average velocity, once we went through this this parenthesis here, your average velocity, your average speed is the ratio of the total distance you move to the total time interval you take to make that movement. So the total distance would be 2.7 kilometers, because we already know that's what it took you. That's what you went since you started driving until you got to the hobby store, plus 2 kilometers because you walk back to the RC truck, right? So the total displacement will be 4.7 kilometers. Now the total time interval would be 0.035 plus the half of hour you walked, plus another half of hour that you walk back to the RC truck. If you add all these quantities, you'll have a bit more than an hour. And if you get the ratio of these two quantities here, you get a average speed of 4.54 kilometers per hour. Okay, and that's pretty much it. That's the end of the sample problem. Like I said, nothing fancy, nothing very complex. All we're doing is just using the concepts of position displacement and average velocity that we learned on the previous video, and just solving a situation. Very, very, I would say, simple, common situation that with those equations, those numbers. So nothing fancy, substituting values. And that's it. Okay, that's pretty much it. That's part 2 of motion along a straight line. I hope you enjoyed this. You found it useful. Of course, I hope you learned something. And if you have any questions, by all means, let me know in the comment section. I'll be more than happy to know about you. And again, I invite you to pay a visit at toysandphysics.com. You can find out more details on that page, on the page of motion along a straight line. Actually, right now, we're just going video by video on different sections, but you can find a full page that's discussing this entire topic with detail. So if you want to find more advanced stuff, you want to find some simple problems or some other problems that I have solved there, by all means do so. And again, let me know if you have any questions. I'll be more than happy to know about you, and of course to help you if I can. If I cannot, I won't waste your time. I will tell you, you know what, this is very complex, but I will do my best. Okay, so that's all I have. That's everything I have for now. I hope you enjoyed it again, and bye for now.